Could we be witnessing humanity's first encounter with alien technology disguised as a simple space rock? The answer might depend on something as subtle as how an object accelerates through our solar system. Decoding celestial visitors, the acceleration test. Here's the fascinating thing about telling spacecraft apart from ordinary rocks floating through space. It all comes down to how they move when gravity isn't the only force acting on them. Think of it as nature's own signature verification system. When we're dealing with natural icy bodies like comets, their movement follows a predictable pattern. These cosmic snowballs get heated up as they approach the sun, causing water and other frozen materials to vaporize and create those spectacular glowing tails we often see in photographs. This process doesn't just create a beautiful light show. It actually pushes the comet away from the sun through a kind of natural rocket propulsion. The escaping gas and dust particles carry momentum with them, giving the comet's core a gentle but measurable push in the opposite direction. But here's where it gets controversial. What happens when we encounter an object that doesn't follow these natural rules? Artificial objects operate under completely different principles. A spacecraft equipped with engines can maneuver in any direction it chooses, regardless of where the sun is located. It could accelerate toward the sun, veer off toward any planet, or execute complex orbital maneuvers that would be impossible for a natural body. This flexibility in movement patterns could potentially shift an interstellar visitor's classification on what scientists call the Loeb scale, a ranking system that goes from 0 for definitely natural objects all the way up to 10 for undeniably artificial ones. This brings us to the main event, 3I Atlas, our latest mysterious visitor from beyond the solar system. The 3I Atlas Enigma. What makes this object so intriguing? Scheduled to make its closest approach to our sun on October 29, 2025, 3I Atlas presents us with a golden opportunity to test these principles in real time. The stakes couldn't be higher. Imagine the global implications if precise measurements revealed that this object was deviating from its predicted gravitational path in ways that suggested technological control. Some researchers have even speculated that such a discovery could trigger market instabilities due to the profound implications of confirmed alien visitation. So, what should we expect if 3I Atlas turns out to be a completely natural comet? Recent observations using the powerful Hubble Space Telescope have revealed some puzzling characteristics. Instead of the typical bright tail of gas and dust streaming behind the object, which is what we normally see with comets, 3I Atlas displays a curious glow that appears in front of it. Even more intriguingly, detailed spectroscopic analysis has failed to detect the molecular or atomic gases that typically accompany cometary activity. Scientists have proposed an explanation for these anomalies. 3I Atlas might be what we call a dust-rich comet. Rather than releasing significant amounts of gas, this object appears to be ejecting primarily large dust particles. These hefty particles are too massive to be easily pushed around by solar radiation pressure or solar wind, which explains why they don't form the typical tail structure we associate with comets. Crunching the numbers for dust particles measuring about 100 microns in diameter. Remember, a micron is incredibly tiny, just 1/1,000,000th of a meter. Scientists estimate a mass loss rate of approximately 60 kilograms per second, with these particles being ejected at speeds of around 2 meters per second in the sun's direction. Interestingly, when they ran the same calculations for much smaller dust particles, just 1 micron in diameter, the mass loss rate dropped to 6 kilograms per second, but the ejection speed increased dramatically to 20 meters per second. Here's the fascinating part. The overall non-gravitational force remains constant regardless of which particle size scenario you choose. Scientists have also used the brightness patterns in the glow to estimate the size of 3I Atlas's core, concluding it likely measures somewhere between 0.32 and 5.6 kilometers in diameter. This translates to a mass ranging from 30 billion kilograms on the low end to an enormous 200 trillion kilograms on the high end. When you combine the calculated forces with these mass estimates, the expected non-gravitational acceleration works out to somewhere between 6 times 10 to the minus 11 and 4 times 10 to the minus 7 centimeters per second squared, pointing away from the Sun. The Oumuamua comparison, a troubling precedent. And this is the part most people miss when discussing these interstellar visitors. The numbers for 3I Atlas look absolutely nothing like what we observed with Oumuamua, our first confirmed interstellar visitor. Back in October 2017, Oumuamua exhibited a non-gravitational acceleration of 2.7 times 10 to the minus 4 centimeters per second squared, a value that's anywhere from 1,000 to 10 million times larger than what we're calculating for 3I Atlas. To put this in perspective, if Oumuamua had been a typical comet producing that level of acceleration through natural outgassing, it would have needed to lose roughly 10% of its entire mass during its brief passage near the Sun. Yet here's the kicker. Despite showing this enormous non-gravitational acceleration, Oumuamua displayed absolutely no signs of the cometary activity that should have been producing such forces. No tail, no coma, no detectable gas emissions, nothing that would explain its unusual movement pattern. Advanced measurement techniques, the technology behind the truth. As 3I Atlas approaches the Sun, its outgassing activity might intensify, potentially making it easier to measure its non-gravitational acceleration with greater precision. Recent research has shown that combining observations from the James Webb Space Telescope, positioned 1.5 million kilometers from Earth at the L2 Lagrange point, with ground-based telescopes can provide unprecedented accuracy in tracking interstellar objects through parallax measurements. This level of precision could be the key to definitively determining whether 3I Atlas is behaving like a natural comet or showing signs of technological propulsion. The controversial timing, coincidence or design. But here's where the discussion gets really controversial. The trajectory and timing of 3I Atlas's arrival seem almost too perfect to be purely coincidental. This object is following a retrograde path that aligns with our solar system's ecliptic plane to within just 5 degrees, a configuration that occurs naturally only about 0.2% of the time. Even more remarkably, its arrival timing positions it perfectly for close encounters with Mars, Venus, and Jupiter, with the probability of such precise timing being calculated at just 0.0005%. These alignments would theoretically allow a hypothetical mothership to deploy smaller probe vehicles that could intercept planets as they move into the probe's orbital paths, taking advantage of the mothership's retrograde motion for maximum efficiency. The fact that 3I Atlas will be hidden behind the Sun during its closest approach on October 29, 2025, means we won't be able to observe whether it releases any such objects into Earth's orbit. The bottom line, data over debate. Ultimately, the true nature of 3I Atlas won't be determined by heated arguments on social media platforms or by popular opinion polls. Just as soccer matches use video assistant referee technology to make definitive calls based on camera evidence rather than player testimonies, the question of whether 3I Atlas is natural or artificial will be settled by precise instrumental measurements and hard data. The scientific method has proven its worth countless times throughout history. Galileo's observations of planetary motion were correct, regardless of the Vatican's official position, and the Earth continued orbiting the Sun for 4.54 billion years before humans even existed to debate the fact. Extraordinarily precise measurements of 3I Atlas's non-gravitational acceleration will provide the decisive evidence we need. As the measured values fall within the expected range for natural cometary activity, we can confidently classify it as an unusual but perfectly natural dust-rich comet. However, as the measurements reveal accelerations significantly outside the predicted parameters, we might be looking at our first confirmed example of interstellar technology. What's your take on this cosmic mystery? Do you think the seemingly perfect orbital timing and unusual characteristics of 3I Atlas are simply remarkable coincidences, or could they be indicators of something more extraordinary? And if precise measurements do reveal technological signatures, how do you think humanity should respond to such a momentous discovery? Share your thoughts. This is exactly the kind of scientific puzzle where diverse perspectives and healthy debate can help us all better understand what we might be witnessing.